Today I want to show you something about area and the proportionality of areas. So let's look first of all at the shape that we have here, rectangle. So this is a length of 5 and a width of 2. Hopefully you know that the area of a rectangle is the length times the width. So the area here would be 10. On this one, notice that it's a little bit longer, so this is 10 and that's 4, so the area on this would be 40. So the first thing that I want you to notice is the area is a squared measurement. So I didn't put any units on this, but if this had been 5 inches and this was 2 inches, then this would be 10 square inches. And 10 square inches means that you have 10 squares that are 1 inch by 1 inch that would fill up this space here. Same thing over here. If this were 10 inches and this were 4 inches, then this would be 40 square inches. 40 squares that are 1 inch by 1 inch. Now, so I want you to notice something else about these figures, that this is 2 and this is 4. So this increased by a factor of 2. If you multiply 2 by 2, you get 4. And in a similar manner, this was 5 and this is 10. So both measurements increased by a factor of 2. Now let's compare the areas. The area on this one was 10 and the area of this one was 4. So notice that this didn't increase, even though this increased by 2 and this increased by a factor of 2, this ended up increasing by a factor of 4. So the area on this one was 10 and the area on that one was 40. I want you to notice something. If we set up a proportion, since this is 2 compared to 4, I could say 2 compares to 4 in the same way that 10 compares to 40. So I'm comparing the widths with the areas, and notice that is not true. If I do that, this is not true here. 2 compares to 4 in the same way that 10 compares to 40 is not a true statement, because 2 times 40 is 80 and 4 times 10 is 40. So to make it a true statement, what you have to do is square those values. So if I take 2 and square it, compared with 4 and squaring it, that compares to the areas. Notice 2 squared is 4. 4 times 40 is 160. 4 squared is 16. 16 times 10 is 160. So to get a true proportional statement, you have to square the widths or square the lengths and compare it to the area. And that's because area is a squared measurement. So think about that. So if we, and we'll look at a problem in just a minute where we don't have all the information, but we're able to figure out some things because of this statement over here, because of the way this works. But before we do that, let's go ahead and calculate the areas of these triangles. Well, this is the formula for the area of a triangle. It's 1/2 the base times the height. The base is the bottom here. The height is this vertical measurement here. So the area of this one's going to be 3, because 1/2 times 3 times 2. 3 times 2 is 6. Half of 6 is 3. So the area of this figure is 6. Over here, there's going to be 27 because it's 1/2 of 9 times 6. 9 times 6 is 54. 54 divided by 2 is 27. Divided by 2 or multiplied by a half is going to be 27 either way. So 3 and 27. So think about that for us. Let's apply our principle here. So notice, because 2 multiplied times 3 is 6, and 3 multiplied times 3 is 9. So these are proportional in terms of their increase there. They both increase, that both of the measurements increase by a factor of 3. Then what we can write down here is that 3 squared is going to compare to 9 squared. I'm doing that right here. So 3 squared compares to 9 squared in the same way that 3 compares with 27. So I'm comparing one measurement, the base, squared compared to each other, is going to be equal to the measures of their different areas. So 3 squared times 27 is 243. 9 squared times 3 is 243. So notice those are proportional, and that works out. So the principle here is that when you're calculating area, you can just take one of the measurements and show how those are comparing with one another squared, and set that equal to the area, and those will be proportional. Now I'm going to show you in just a second how that can be helpful. All right, so all of that means, let's consider a surface area problem with some cylinders. Let's suppose that the radius is 3, the height 7, and over here we know the radius is 6, but we don't know the surface area, and they didn't give us the height. Well, we can figure that out with proportionality. So what I did was I'm going to take 3 squared and say 3 squared compares to 6 squared over there. Because we're talking about area, we're squaring one of the measurements, 3 and 6. Now, I didn't use 7 because I don't know what this one is over here, but if this is 3 and that's 6, then it's 3 squared compares to 6 squared in the same way that, and let's suppose they gave us the surface area on this, or we calculated it using this formula, then we would know that it's 188.5. So I'm saying 3 squared compares to 6 squared in the same way that 188.5 compares to what? So the surface area, SA, the surface area of this one over here, that's what X is going to be. Well, anyway, if you cross multiply, 3 squared times X is 9X, 6 squared times 188.5 is 6786. And if you divide, you get 754. So what I'm saying is this: the surface area of this one over here is 754 square meters, just simply based on the 3 and the 6 and this surface area over here. So one measurement squared compared to the other measurement squared equals the surface area of this figure divided by the surface area of that figure. I was able to figure out what X was, even though I didn't have all the information here. So that's the benefit of this concept. Hopefully this makes sense to you. It means that we can solve all kinds of area problems using this proportionality. So just keep in mind, it's not a direct proportion. We're not saying 3 compares to 6 in the same way that this compares to this. What we are saying that 3 squared compared to 6 squared is going to be proportional to the surface area ratio. Anyway, so how this applies in volume is you can do the same kind of thing with volume, but it'll take one measurement cubed, because with volume, you have a cubic measurement. In other words, your answers for volume are going to be cubic meters, cubic inches, cubic feet, that sort of thing. Well, I realize this has been a load of information. Hopefully this makes sense to you. If it doesn't, shoot me a question in the comments and I'll try to re-explain this and do a better job next time. But if it makes sense, give me a thumbs up. See you later.